This is as following. There is an ice cream parlor outside. There is an ice cream parlor. So we got three sort of ice creams: Amul, Vanilla, and Mother Dairy. Let's call them ABC brands are there of ice cream. Now the person selling ice cream feels there may be a effect of income of the person on the choice of the brand. There may be an effect of income of the person. It may be high income people are going for A category of ice cream, low one are going for B or C. So what he does, he collects the data. So whosoever comes, he simply asks how much income you have, actual income, monthly income, and then which ice cream I should give to you, A, B, C. So for this, can you tell me which sort of statistical tool or technique will be applicable? So objective is to study the effect of income on the choice of ice cream. T-test is okay, or correlation. I told you, the ice cream person, whosoever comes, he simply asks her or man, what is your income, monthly income? 8,500 rupees or something like that. So people reply, so this is, and then says which ice cream I should give, A, B, C. Take your ice cream. One way no. Okay. So how you decide it? Like it's a Sunday, so we should apply one way no. On Monday we'll apply something else. Or it's a bivariate that I agree. First tell me, did you get a link yesterday for downloading the files? So do you have that file with you, Excel file?
Yes.
Do you intend to use this file? Are you planning to use this file, or you will go just the way you work? So let's see. How many variables are there in my query? Ratio. Exact income is the ratio. And choice of the ice cream? Categorical, non-metric, which? Nominal or ordinal? Nominal. There are the three words. Okay. So now which one is dependent, which one is independent? Choice depends on income. So just look for the three steps which I narrated yesterday. Just look for the three steps. You shouldn't be quick in answering. Just look for the three steps. So dependent variable is one that is non-metric.
So linear discriminant analysis.
Linear discriminant analysis is the correct answer. How you jumped at one by no? Simply there is one metric, one non-metric doesn't mean there is a one by no. One metric, one non-metric, it can be any of the two. It can be hypothesis testing. If dependent is metric, it will be logistics regression or LDA, linear discriminant analysis. If dependent is non-metric. Are you able to connect to this? So here dependent variable is non-metric, independent is metric. Actually this name is, instead of binary regression, you should write logistics regression. So just see these two parts in this table number 2. Just look at this one and this one. They are similar in the way that there is two variables. One is metric, other is non-metric. So when dependent variable is metric, independent non-metric, this is a zone of hypothesis testing. Since it is non-metric, also called as the categorical, we said okay, how many categories we have? If the categories are 2, name is logistics regression. Here, dependent is categorical. If there are two categories, we will apply binary regression. If there are more than two categories of what? Of dependent, more than two categories of DB, then we apply multinomial regression. So just see, they are diagonally opposite. Here the concept is hypothesis testing. Two categories of identity test, more than two, one way around. Here, two categories of this binary regression, more than two categories multinomial regression. So, logistics regression or LDA, these are two separate things. Their algorithm differs. LDA is actually now obsolete. People don't use it. Still in academics people use, but generally people go for the logistics regression. LDA is used very less. So, in both, we can use logistics regression, we can use this depending on how many categories. So, correct answer for the question I asked, effect of income on choice of ice cream. Where ice cream, there are the three brands A, B, C, and income is, question is asked, what is your income dash? So, it is the ratio. It is nominal. So this is metric, this is non-metric, this one is dependent, this one is independent. So correct answer in this case is exact answer is multinomial regression. So it's okay if you don't plan to use it, but it's something like you should know conceptually. See, I think number of people are here from Lucknow city itself. So the people of Lucknow, resident of Lucknow, have you visited every single street of Lucknow? No, but conceptually you know this particular is that side, Kent is on that side, this one is on that side. Conceptually you know. Just like here, conceptually you should know which will be applicable. If you wish to apply anywhere in your work, you can simply write multinomial regression on YouTube. You will get the videos. But if somebody is talking about I am working on the binary regression, you should know the context. That what they are talking about. Binary regression means their dependent variable is categorical, having the two categories. Yes, no. So that's used a lot. Then there was a question of what exactly is a two-way node? What exactly is a two-way node? So let's try to write an objective to study the combined effect of gender and residential status on marks of students. To study the combined effect of gender and residential status. To study the combined effect of gender and residential status on the marks of the students. Question number 1, the first question. How many variables are there? 3 are the variables.
There are 3 variables, but we have not applied split rule.
We can
Split rule.
we can apply split rule. Apply split. Can you bifurcate?
Male and female.
Can you do that? The word combined prevents you in splitting. The word combined means effect of both need to be taken simultaneously. If the combined word is not there, it actually becomes two bivariate. You can see the effect of gender on marks means girls got more marks or boys got more marks, and effect of residential status means people from urban background have high marks or people from rural background have high marks. But the word combined prevent you in splitting. So can you split now? You can't do it boy and girl, because if you do it separately, then combined effect will not be visible. So basically, had it been like to study the effect of gender, so we will see what are the marks of boys, what are the marks of girls, and let's check them. If both are same, null hypothesis, both are same. If this is a separate, it means being a boy or girl will not get you any marks. Marks of boys and girls are both same. There are other things on which marks depends on. Are you getting this inference? Are you understanding the inference? If I will say average marks of boy or average marks of girls are almost same, then what it means? Will it then affect the marks or not? Okay. So you have not gone through this inference. Okay. So I will explain you a little about this, but just study. These are the two parts. If combined word is not there, we can split it into the two parts to study the effect of the essential status of this for boys and girls. Or we could have done this way to study the effect of gender on the marks for urban and the rural people. We could have done it too, but now the word is combined. Combined means both have to be taken simultaneously. Both means we are talking about urban boys, rural boys, girls from urban and girls from rural. There are the four groups. We are looking for the four groups. Combined effect. Okay. So since we can't split it, it's a case of multivariate analysis. It's a case of multivariate analysis. Three are the variables and we can't split. All the three are there. So refer the table number 3. Can you tell me which one is dependent and independent? Marks is dependent. And how we measure the marks? Actual marks I have taken out of 100. What is the measurement? Metric or non-metric? Metric. Which one in metric? Interval or ratio? Ratio. Out of 100 actual marks I have taken. Okay. Now refer to the table number 3. Table number 3 suggests that we have 3 variables. How many dependent variables? 1. And is it metric or non-metric? Metric. So it means any of the 3 will be applicable. Is that true? Any of the 3 will be applicable. Dependent variable is 1 and that's metric. Look at the independent. Independent, whether all are metric or all are non-metric or there is some metric other non-metric. All are non-metric. The point written is n being lower and n is written on the bottom. N means number of non-metric independent variables. Number of non-metric independent variables. So how many non-metric independent variables we have? 2. So the correct answer is 2 by alone. The correct answer is 2 by alone. Are you able to connect to? I understand maybe this is something you have never touched on. It's perfectly okay. I'm just saying it's not that tough. Just look at the 2-3 fundamental things. There is nothing more in research than 2-3-4 fundamental questions. The fundamental questions are how many variables, their role, dependent, independent, and the way you measure. That's it. All doors will open in the research by only the 3 keys. These are the 3 things. You go for up to any level, always the 3 questions will be asked. The language of statistics is this. So we have this the case of multivariate. So now just see the effect of if I make little change in my earlier objective of ice cream work. To study the effect of age and income on the choice of ice cream. To study the effect of age and income on the choice of ice cream. How we done it? We have done it that what is your age? Dash years. What is your income? Dash monthly income. And which ice cream you like? A, B, C. So here 3 variables are there. Okay. Now we have not written the word combined, so we can actually think of splitting into 2 parts. Splitting into the 2 parts. But here you need to remember one little thing. Have you seen the movie Batman?
Yeah.
So who's the villain in the Batman? hero is incomplete without the villain. Villain is necessary. Without villain, there is no story. If you just read Ramayana once again, Ravan Sita married went to this. If there is no Ravan, and then come back, there is no story. The story is always there. Joker is the villain. Okay? So you name for anything. If you talk of Spider-Man, then there is something else. If you talk of Captain America, Hydra is there, or someone else is there. So villains are very important. So the villain in the statistics are two. Two are the villains. Okay? You do anything, these two villains will come. So it's like Spider-Man, then these villains will come again and again. So these two villains are, one is outlier, the biggest villain, outlier. And how you identify this is there. So for the outlier, we have made a concept called normality. If normality is there, you are happy there is no outlier around. So if there is no normality, just think of outlier as well. Okay. The second villain is multicollinearity. Multicollinearity is the R between independent variables. R relation between independent variables. Now the point here is, I said age and income, two independent variables are to study the effect of age and income on the choice of ice cream. Now what do you see? Age and income, what do you see? Will there be a relation or no relation? There will be a relation. As the age increases, income increases. In most of the cases, there will be a relation. So when there is a relation, now there is not a choice whether you can work simultaneously. You have to take their combined effect. You have to take their combined effect. Please understand this one particular thing in writing the objective. When you write your independent variable and they are non-metric, by default they will be considered separately. You have to write the word combined to take their combined effect, else they will be taken separately. When you take the word, take the independent variables as metric, you cannot take them separately. You cannot. There is a compulsion on you, take them together. See their combined effect. Whether you write it or don't, you have to see the combined effect, because only then multicollinearity will come into picture. So if you take one variable, if you take another variable, you won't get the real picture. The real picture will come when total they are in one. Okay? The moment they are in one, so it's something like joint family. All power and politics and everything will start when people are together. Then the fight will start. So multicollinearity is again sort of that fight. So let me just repeat what I said. I said that when there are a multivariate case, number one, multicollinearity comes only in the multiple cases, not in the bivariate, not in the univariate. When you have the many independent variables, if all of them are non-metric, by default you will take them one by one. Principle of split will apply until and unless you write the word combined. So if you write combined, then they will be taken together, else by default they will be separate. If your all of the variables are metric, you need not to write combined. There is a compulsion, you see, has to see their combined effect. There is a compulsion. There is no meaning of measuring them separately. There is a compulsion because of multicollinearity. So in this case, to study the effect of age and income on the choice of ice cream, there are three variables. Two are independent, one choice is dependent. Okay, and two are non-metric, both are metric. Actual age, actual income. So we have to see their combined effect. So look for the table number 3, and can you tell me which? Logistics regression is the correct answer. Logistics regression is the correct answer. Are you able to connect? Yes or no?
Yes.
With little hiccups, digest it. Just see, if I simply change a few of the things, if coming back here, coming back to this, to study the combined effect of gender and residential status of the marks. Marks I have not measured as actual marks, I have measured it as first division or the second division. Marks more than 60% considered first division, less than 60% second division. Now, what is the measurement of marks now? Is it metric or non-metric? Non-metric. What in non-metric? Nominal or ordinal? Ordinal. Now, do you see the choice of the test or technique will change? Choice will change. So, looking at the table number 3, can you tell me what should I apply now? Log linear integration or complex cross tab. Layered cross tab or the complex cross tab will be there. So, do you see it actually depends on me. The way I will measure something will decide which tool or technique I will apply. Are you clear on it? You are free to measure anything in whatever way. So it's a 3-step process. Your objective, measurement and technique. From the objective, you can measure in whatever way. Once you measured something, then you are not free. There's an interesting anecdote. One person went to Gautam Buddha and asked, you always talk of this, law of karma, etc. What exactly it is? So Buddha said, lift one of your leg. He says, okay, lift it. Now he said, okay, while keeping this in air, lift the second. He said, well, how can I do that? But this is, when I said lift the one leg, you are free to raise any of the leg. I didn't say lift the right leg. You could have taken any of the leg. Once you have taken, now you are bound by the other. You can't take while other is up. Similar is the case with us. It's a 3-step process. Objective you can measure in whatever way. You decide, metric or non-metric, whatever feels okay to you. Once you decided, now you are bound. Now your choice is lost. Once you decided, I have taken non-metric, accordingly to technique will apply, or you apply say metric, accordingly to technique will apply. Do you get this process? So ultimately, most of us starts first making a question, totally reverse engineering. So now, first think of the variable. Think of the variable, what was my variable and how I measured it, metric or non-metric. And then naturally flow will be, look for the table number 1, 2, 3. So now let's start with RStudio. In the RStudio, I am opening the file. So it's attached, empty cars. Is it visible? I think this is the maximum I can do. Empty cars and then view empty cars. Now I got the 4 pages. So 1, I have these empty cars, 32 are the size and these are the 5 variables. MPG, cylinder, displacement, etc. These are the things. So one method to check whether my file is attached or not, write the name of any one of them like MPG. So you should see, press enter, you should see all of the values here. 21, 21, the next one is 22.8, 21.4. You can see this. So what is meant by this 6 and 11? Actually, R is very intelligent. It always looks how much width is available. Like if I increase the width and I read on this MPG, now see, it is up to this width, right? 8, this is the 9, 10, 11, 12, this is the 17, 25, 6, 7, and this is the 32. So this is 31, 32. So depending on the width available, it will automatically do your work and keeps numbering. So these panes you can change as per your convenience. Now since I got very less space, so I am minimizing this empty cars. It's not closed, it's there, but I am minimizing it. Now yesterday we started with univariate analysis. In the univariate analysis, what are the things? Mean, median, minimum, maximum, standard deviation, variance, quantiles. These were the things which we have done. Then I told you that we require certain package called node test. So let me see, do I have node test? Yeah, I have this package node test. N1, you must have this. If you have the node test, then call it require node test. Just see one thing before that. When I write skewness, 3 alphabets you should write and there should come a drop menu. If the drop menu is not coming, I have done skew and there is no drop menu, it means this particular function is not available in the base folder. Right? So there must be some package attached. So let me attach a package REQ node test. Now the moment you write the skew, us movements. Require movements. So let me check here. Node test. I missed it. Node test is for normality checking, not for skewness. So the name of the package is movements. So if it is not installed and you have access to internet, just install. It will take a minute or so. Moments. M-O-M-E-N-T-S. Node test is for normality test. Moments is for checking the skewness and kurtosis. Require moments. And now when I write skew, do I get a drop menu? Yes, I got a drop menu. So drop menu suggests me that yes, the skewness is now over. You must go to require moments and then you can go ahead. If moments is not available, take a moment, install it. In the word of our, whatever you require, just install. Internet should be there with you. So just install moments. Two are the ways to call a function, either require or library. Either require or library, both are the same. You know what happens generally? In modern day software, you can do the same thing in a number of ways. In Excel, the same thing you can do at least in 4 or 5 ways. So in R also, there are more than one ways. So now we get the skewness. If you do not have moments, when you write SKEW, nothing will happen, no drop menu will come. You call moments, require or library moments, and then type SKEW, a drop menu will come, skewness. Now I wish to check for the skewness of MPG. So it says 0.64. 0.64 and kurtosis of FPG comes out as 2.7. Now this won't teach you statistics. This is a calculator. So you should know what should be the value of skewness and kurtosis. For a normally distributed data, the value of skewness should be 0. For a normally distributed data, the value of skewness should be 0. And value of kurtosis should be 3. For a normally distributed data, the value of skewness should be 0 and value of kurtosis should be 3. Okay? So whenever I will talk about the normality, all you need to remember is I am checking whether there is outlier or not. So in other words, if the skewness is 0 or almost 0, if the kurtosis is almost 3, there is no outlier present, normality is 0. That is good. Outlier is not a typing error. Outlier is a real number which is very far away from the rest of the data, very large or very small. So we have completed the univariate analysis for the metric data. Metric data, we can apply mean, median, mode, no, not the mode, mean, median, standard deviation, variance, minimum, maximum, quantile, skewness, kurtosis. Now all of these we can do in one shot, require summary tools. Require summary tools. Initially you may think like, how do I remember all these things? But don't worry, it's just a third hour of working on that. You spend some hours so you remember. I just want you to recall day 1 when you are working on MS Word or MS Excel. Today you are so comfortable, but on the first day you are very uncomfortable what to do with the mouse and all these things. So with the passage of time it will come. Now I am writing a function DESCR. DESCR. So there is a way of working in R. R always writes the same. Whenever in most of the countries we have a name and a surname. We have this Prime Minister Narendra Modi. The name is Narendra and Modi is the surname. So my name is Neeraj Kaushik. It means name tells you something and then surname also tells you something. In certain parts of India, for example in Maharashtra, it's mandatory to put the name of your village also. And if you go to the South India, that's why the name is so large. It's your name, your father's name, and the grandfather's name, and the name of the village. So basically, your complete name is a postal letters. Name, son of, and the village. You simply write, that becomes a complete. In certain parts of Kerala, the father, grandfather, and grandson will have the same name. So one of my colleagues told me. So his name is Philip, Jacob, etc. So his son will be Jacob, his son will be Philip, his son will be Jacob, his son will be Philip. So alternate. This happened in some time in Rajasthan also. Mansingh and Jaisingh alternate. Okay, Mansingh and Jaisingh. Again Mansingh 2, Mansingh 4, Mansingh 5. So I was just telling him, you should have, passed some resolution that we will repeat after third or fourth generation. 2 generations are too low. But these are the traditions. So here we will be, what we will do, there will be a function and there will be a package. So just see, you may not see here, if you write here, DSCR in complete places it's hidden subtitles. You may not see it here, but there is always a tradition of writing the function and the name of the package. So if I remember, I can write DESCR, or other method is, I remember the name of the package, summary tools, colon. Now it means I ask it, tell me, show me the functions which are available only in the summary tools. I don't want to see the whole list, I may get confused. So tell me the list which is already in that package. So it's always a good idea. Name of the package, colon, and then only a very small list will come which are available in that package. Do you get the meaning? There are the 2 ways. So if you are working on an altogether new package, it's a good idea. Write the name of the package, colon, then only the name of the functions of that package will come. That's always a good idea. So now in the summary tools, and second, the moment you don't click OK, coordinates, etc. of the data. Just like MS Excel, it requires simple English. Just read this, it will help you. Okay, of MPG, and now it says okay, you need not to do it these much times. So let me help you. So in one go, all of the things are computed. Earlier we were writing so many functions, mean, median, SD separately. Now it says in one go, your mean is this, standard deviation, minimum first quartile, maximum mid quartile range, skewness, kurtosis, all these values are there. In one go, you can compute all. So,
value kurtosis was 2 point something last time.
Correct. Actually, I will make a separate video on the kurtosis. That's one of the most mysterious things. Kurtosis, have you read it in syllabus? Generally, it's not the part of the syllabus. Skewness is there, kurtosis is not there. The concept is movements. Okay, so which movement you take, there are multiple methods of calculating the movements. Computing from the first movement, second or the third movement. So actually kurtosis is not one, there are many kurtoses, depending on which point you are taking. So that's why different packages contain different values. And scholars have a confusion. So first we should know the manual calculation steps. This happens in a number of ways. Like we'll talk about today, we'll talk about 11 test. 11 test can be computed by 3 methods, by mean, by median, and then by mode or something else. So that's why the different packages have different meaning. So this is the interesting thing. In SPSS we never challenge. We believe it's like written in the Old Testament or New Testament. SPSS says we believe, yeah, that's okay. We never argue that what are the calculation steps, because we never do it manually. We believe that SPSS is doing this kind. But R gives you this freedom also. You can have the, if you want other thing, there is a other package. Computing kurtosis by that package will give you something else. So you should know that. It tells you N valid. It tells you about the missing frequency. N valid means 32 cases are present, none is missing. Had there been 2 missing, so it will say N valid is 30, total is 32, so 2 are missing. So this gives you a V5. Now let's come to the second part. Second part is how to handle the non-metric data. So far, I have not talked about the non-metric. Let's talk about what is how to handle the non-metric. Metric we have done. You can work in one shot by summary tools, descriptive. Please remember, this is a word coined by SPSS, actually two are the words which now becomes research words. The two words given by SPSS, wherever you find the term descriptive, it means univariate analysis. Mean, median, mode, minimum, maximum range. Descriptive means this. Wherever in the in SPSS sub-menu also, if you get the descriptive, it means do you want to calculate the univariate analysis. And the second word is factor. SPSS calls a non-metric independent variable as factor. A non-metric independent variable is called as factor. Non-metric. And the same terminology R will also comply with. Non-metric independent variable, it's always called as a factor. So first let's understand little bit of very little details of so let's understand. Let's talk of something when the developers of computers they faced in 1960s and 70s. When we talk, we human beings talk of the things. Our data, whatever we talk of, generally consists of two words, either text or numbers. That's it. We talk, human beings talks in two ways. One, the text, second, the number. Majority of the time we talk in text, but we do talk in terms of numbers. The numbers can be again categorized into many. So, in the school level, did you get that understanding of natural number, whole number, integer, etc.? You have gone through that? Natural number, etc. Well, I have an observation here. I want your opinion. I have a feeling it should not be called a natural number because these are the numbers which human beings have developed. Yes or no? Human beings, my question is, we the human beings, we have developed numbers or numbers were already existing in the nature. My query is, when you call it as natural number, it seems other species are also using numbers. Do you know any species who know numbers? Or numbers were coined and designed by human beings? What's your point of view?
They know numbers, but they don't have the name of particular number that is 1, 2.
They know numbers? They know? Have you seen doggies saying like, okay, 9 a.m. it's time to bark. I must go out and I must do something. Or 10 a.m. now I should sleep.
So like ants, they move accordingly.
They move. But they do they have numbers? Every species has some little understanding. Okay? The species are of two types. A nocturnal who walks in the night, who walks in the day. Okay, that's okay. But my understanding is, do human beings devise the number? Or numbers were already there? Can you tell me any number which was present even before we understand this concept of number as well? Yes? What is that? Not a good question to be asked on Sunday morning? You have come this way, sacrificing your Sunday and asking these stupid questions, whether human beings were first or numbers came first.
The numbers were always there.
Really? Okay. So, 1, 2, 3, 4. So, we discovered the number, we did not invented them. Do you agree?
Yes.
Give an example then. Tell me any number which was existing earlier. Zero. Fantastic.
Going to
Then-
take example you gave yesterday.
What?
How the days of the week started. How we.
Well, that's a long story. That's days of the week. Our ancestors were very happy people. There was no calendar. Somehow they were able to decipher that it takes 365 days to turn one. That's making very simple. If I go out, I just put a line where the sun shadow is there, and I write the name, date, etc. After exactly 1 year, the sun shadow will come exactly on the same point. So this if you are vigilant enough, you understand there are some patterns in the nature. Sun movement is a fixed, very much fixed. So initial Roman calendars were, there was like 12 months of 30 days each. So people asked what about the rest 5 days. The emperor said that's about it. So there was no calendar. So that's why Gregorian made a calendar. And calendar again got a wonderful history. Why February got 29 days, why August got this much days. This is a complete history of that. But coming to this point, numbers existed before human beings, is correct. And all species or majority of the species, they know the numbers. It's simply they don't have zero. It's only human beings that have zero, and that's why we have algebra. Complete numbers, others one. So if you don't believe me, if there is any sparrow who has given some eggs are there, you take one egg out and just see the behavior. Sparrow will come to know. The bird will come to know. If there is any doggy and some puppies are there, you take out one puppy and see whether the dog will come to know or not. They know the numbers, and not only this, they know up to 9, they know up to all. They know up to all the numbers, but only thing is they don't have algebra. So human beings, it's not that right from the day one we had algebra. In Roman counting, till date, you can add, you can't multiply. There is a C and the D. Remember that? 1, 2, 3. You can add, you can't multiply because there is no zero in the Roman algebra. Okay? So, is there any number which existed before? Yes. At least 2 numbers are there, and they are just wonderful numbers. One number is pi. Till date, we don't know what is pi. Till date, we do not know. Whenever it's a supercomputer, the first task given to supercomputer is up to how many places we can compute the value of pi. We have gone up to 1 lakh decimal places. Every single day we are going, but we still don't know what is pi. So people in mathematics, they have a love for pi because we don't understand what is pi. And second is golden ratio. So just for your kind information, the pyramids of Egypt can be anything. They are not certainly a burial chamber for some dummy mummies, etc. Absolutely not. Pyramids are mathematically supremacy. Mathematics at the highest level, at the pinnacle, is the pyramids. Just wonderful, awesome. And the pyramids make use of both the numbers, golden ratio and the pi. This is an interesting question for all those who are science students. How do you know 1 meter is this much? Today we know you have certain count, but how do you know this is 1 meter, not this much or this much? Who was the first person? Someone must have done that this is 1 meter. Again, that's a golden ratio minus pi has something to come with that, and that was done some in BC, not in modern days. That was done. So it's again, this is really very fascinating. Coming to this part, first let's understand how we human beings feel, and then we'll try to tell our computers. There is a text, there is a number. The numbers are D6, a natural number, whole number, etc. All these things. Let me call it as numeric. In the numeric, we understand it ratio measurement, where 4 is exactly 2 times 2, and 6 is 3 times 2. Okay, so it's a numeric. Whenever you write any numbers, computer will always take it this. But then we say, no, there is one more thing. We will write the numbers, but it won't be read as this. For example, this is called date. So 1-3-2020. This is nothing but the numbers, but we will say no, these are not the numbers, or number in a particular way. This is day, this is month, this is year. These are same numbers, but with some separator, the meaning is changed. And then there is a third one called factor. Factor means there is 1 and 2, but 1 means y and 2 means girl. 1 means y and 2 means girl. Okay? So this is what? This is nothing but non-metric. This is non-metric. So this is called the data type in R. For any programming language, you actually has to start with it. So when C started, they need to make computer understand what the number is. So they said, they have gone a long way. They said, well, there is up to 32,000. This is a short number, then there is a long number. If decimal is there, it's called float. Decimal will be there or no decimal is there. Then is it a date? Is it a numeric number? Is it a factor? So in R, we will talk of a number of things. But to begin with, I will take only 2, either a numeric or a factor. I will take either a numeric number is that's a ratio, and we will convert the number as the factor. By default, the moment you write anything, for example, 4, 6, etc., or today this will not work. When I come to this Vs, just see here. Now what is Vs? You remember there was a coding. 0 means V-shaped, 1 means automatic. 0 means manual, one means automatic. Okay, so it means these are the codes. But computer doesn't know. Computer will know this is 0 and this is 1. So it can add them, it can subtract them. But we are saying no. These are not those numbers. These are not numeric. By default, the moment you write anything, you remember where from this comes? This comes from the Excel file, data entry. I'm skipping that part. I believe you know about the data entry systems. From that questionnaire method, you can convert the data into in the coding form, and then you put it into Excel or SPSS. Now our first job will be to tell the system that these are actually not the numeric. Reason being, if I just ask here, just say one thing. One method to look at it is summary. If I do summary of FPG, summary is another method, a short method of finding out the minimum, maximum, mean, median. We could have done it singly like mean, median, minimum, maximum, range, etc. Standard deviation. Other method is summary. Now, if I ask for summary of VS, it says minimum is 0, maximum is 1, mean is 0.43. Now, this is meaningless. Because V means a particular, like boy or girl, then mean 0.43 is meaningless, there is no meaning of it. Why it is taken this way? Because it believes VS is a numeric. So first step will be, whenever you have a non-metric, first you need to tell the computer, it's not non-metric. What is it then? It's factor. So how to tell? Let me say V is a new variable, as dot factor, VS. So this is called sort of a conversion. I convert the data type. Convert is a good word, but R call it somewhere, I don't know why the word is coercion. Okay, not a good word, coercion, but this is what it is, coercion. So coercion is converting the data type. So whenever you have a non-metric variable, the very first step will be, you tell R, it's not a numeric, it's a factor. You understand what is a factor? Factor means you will actually count this. How many times 0 is there, how many times 1 is there. You don't add up or do their mean, etc. Now I should say, okay, I got it. Where is this V? V you can find here. Now see what is written on the V. V says, I understand it's a factor with two levels. It says I read the data, there are the two levels. If there is 0 and there is 1, that's it. Only two things are there. I understand it's a categorical question with the two categories. Now let me do the summary of V. And what we expect now, it says okay, now I will, summary means I should count them. Since it's a factor, so 0 came 18 times and 1 came 14 times. Does it make sense? Do you get this first step? What is numeric, what is factor? Numeric is ratio data. So whenever you add, whenever R will see any digits, it will say this is numeric. You need to tell it, no, it's not numeric. So what is the command? As dot factor. As dot factor means you are telling R, this is not the numeric, this is a factor. Now what is a factor? Factor means categorical. They are not added, they are simply counted. How many boys, how many girls in my class? That like that. But it's better if you can write 0 means V-shaped engine, 1 means straight engine. That is, we have to give the label. We have to give a label to that. So how to give the label? Now let me make a new variable VV. And this label is available in the factor. The name of the function is factor, in which one of the argument is label. Please look, these are two separate things. Don't get confused. People get confused often. Fact as dot factor is a convert command. That's it. At the time of conversion, it will it will come to you. Can't I do it at that time? That 0 means 1 means this? No. You had to do it in two steps. Step number 1, as dot factor. That's convert. Once it is converted, then use the command, use the function factor, where you can give the labels. So it's called this V, comma, label. Please do not type. Use the drop in. Spellings are very important. It's not L-A-B-L-E. It's L-A-B-E-L. S, labels. C. And now we'll write what is 0 and what is 1. One is V-shaped engine. and the other one is straight engine. Please look for this particular way. Let's narrow down every single thing. Number one, I have written factor. What I have written in this way also. See, the way we write. Number one factor, this is the name of the function, bracket v. V means which we are talking about. We are talking about the v. Variable is there v, comma, labels c. C, yesterday I told you whenever you write C, it means concatenation. It means read in this order, wherever respectively. Wherever you will find C, a small c, it means read in this order, respectively. So, those who have worked on SPSS, they know that while working on the labels, we need to specify 0 means while, at, 1 means well, at. R says, don't tell me 0 and 1, I know that. I have the data, I know 0 and 1, I can put in the ascending order. You just do one thing, in the ascending order, you give your labels. It means, this will go to 0, this will go to 1. If your data is in 1, 2, 3, 4, this will go to 1, this will go to 2. So R says, don't tell me about 0, 1, 2, that I know, and that I will put in ascending order. You just do one thing, you give those in the order. That's why we are using C in this order. So first one will go to 0, second one will go to this. So this is again from the Excel. In Excel, whenever we write text, it's written in double quotes. And whenever you write numbers, you can write numbers directly. This is again the Excel view. In Excel, when you write cell address is written directly, number written directly, text is written in double quotes. This is the rule of Excel. R is following the same thing. So we write factor, bracket V, labels is equal to C, concatenate in this order. Inverted commas, V-shaped engine, not the engineer, V-shaped engine. And the other one is comma. Comma means, now is the second argument, state engine. Bracket, this bracket close and this bracket close. That's why the two brackets are there. Okay. Press enter, and now let me find out the summary of VV. So it will tell me V-shaped engine. Okay, I will tell engine. This V-shaped engine are 18, straight engine are 14. So just look for this one and try to go for AM. A means in the variable AM, 0 means automatic, 1 means manual. AM, 0 and 1. 0 means automatic, 1 means manual. Please try to convert AM into A or AA and A. If you understood this concept, please do the same on AM. Convert AM into something. That something can be anything. You give A or triple A or whatever, that's immaterial. Convert AM as factor and then give the code 1, 0 means automatic, 1 means manual. Please give this. So convert AM first into the factor as dot factor AM and find out its summary. You will just read how many times it's there. And second, give the labels. For the labels, we use the function factor. And labels, please don't type, use the drop menu because the spelling of the label is LABELS, not LABL. Use the drop menu as far as possible, as much as possible. We will do it into two steps. First is as dot factor and try to see its summary. The summary will be 0 is 19 times, 1 is 13 times. And then give its labels, automatic and manual, and then see the summary of this A. Automatic is 19, manual is 13. This is the same thing which we need to do in any software, SPSS, SysTat, coding you need to do. You need to do the coding. Even if you use some admin functions like megastat, coding is there. This is required in the two-step process. As dot factor is simply conversion command. Factor is a command used for writing the labels. These are two separate commands. Nothing in common. These are two separate things. As dot factor and second is factor. So as dot factor simply converts into the numbers. If you find out the now I have the three things. If I find the summary of AM, that will be something like mean, etc. It will give. If I find the summary of AM, it is treating AM as an unique variable, which is not. So we convert AM into the factor. So it understood. This is 19 times. It is 13 times. And when you convert it, it gives you the label. By default, see, it will treat AM as if it's a numeric, 0 and 1. Please answer the doubt. Okay. Just so that we are not confused. Otherwise, if you can do, see, how to remove these things. If you wish to remove this, it's RM. RM for remove. A and AA. Let me remove this. Just see. I have one thing, summary of AM. It is taking it summary as numeric. First, I converted it, let's say A is equal to as dot factor AM. Now, summary of A, now it's okay, 0 and 19. Okay. Now I want to give a label, so that you are not confused. Otherwise, we could have written this way also, is equal to factor A, labels, see ma'am, what will happen now? Please read it from backside. Give a label, automatic and manual. To whom? To A. Where is A? A is here. Factor is the 2. Okay? Okay. After doing this, what to do it? Save it in the A. Okay? So read it from backside. Give the label automatic and manual. To whom we will give? To this A is already there. That's why I have written A. This A is this A. And then I said, after doing all of this, overwrite on A. In the first step, I was writing A and A separately, so that we are not confused. Okay? We could have done this way also. This is overwrite. Okay? So if you are comfortable, then you can make this way. Otherwise, we could have done it this way. That let me make it as AA. So that now I will get A also and AA also. So just see, now I got A and AA. If I find the summary of A, it is like this, and summary of AA, it is like this. Can you see there is a difference between A and AA? Actually this A is actually of no use to me, 0 and 1. But I am just doing it so that initially you should not confuse. You can make separate, or you can actually overwrite this A. Instead of A, you can overwrite. That's okay. That's perfectly. Can you do the same for cylinder also? in the cylinder there are only three categories are there, 4, 6, 8. So give the label. 4 means 4 cylinder, 6 means 6 cylinder, and 8 means 8 cylinder. Convert cylinder into CYL is the name of the variable. Convert it into first S dot factor and then give the labels. CYL. This is available here, CYL. So if I first begin with summary of CYL, it will take it as metric because it is finding mean is 6.8. There is no meaning. There is a 4 category, there is a 6 cylinder category, 8 cylinder category. 6 point something is meaningless. So what we will do? We will say, let's say C is equal to S dot factor CYL. Now it understood it. So okay. Now I got it. Summary of C. Now we say 4 is 11 times, 6 is 7 times, and 8 is 14 times. I convert it as dot factor and then find the summary. But now I want its a label also. 4 means 4 cylinder, 6 cylinder, 8 cylinder. Use the command factor. Use the command factor for that. So you can save it in your script also for the later use. You can work on the script also. You can type in console, work there, you can work in the script. That's one and the same thing. Don't worry about that. You can type in console, later put it into the script. That's not the issue. So this is available with me. I can save it. Let's say A2 dot capital R. A2 dot capital R. But just I have changed from C to CC. I have changed that. So now you have, see once again where we are. You complete it, then we'll just make a summary of it. This is the only part that takes a little time for understanding. Rest of the things are so simple. We'll just click and answer. Rest all the things are so simple. We'll just write, enter, and you'll get the results.
Similarly, we can define some modes of vector in LL, CCCC.
It means the very first task for you is to make R aware that these are factor, these are numeric. By default, it will take everything numeric. By default, everything is numeric. You need to tell these are the factor, others are numeric. 11 अब x में चला जाएगा। अब ये ठीक उसका यानी हमेशा हम क्या करेंगे, आउटपुट को किसी चीज़ में डाल देंगे, उस पर फिर आगे काउंट, फिर किसी में डाल देंगे, ये प्रोसेस काउंट। Okay, shall we go ahead? Now just see once again where we are, because there must be a common thread. We must know where we are all the time. So we, in the conceptually, you have done your research, you have collected the data, questionnaire method or otherwise. Now the data is with you in the Excel format or text file or format or whatever format. When you enter data into Excel format, it means you understand the concept of coding and data entry. That's an assumption, I believe you understand that. So, for example, boy, girl, coding 1, 2 will be written and that's entered. After that, you import that file. Now we are working on the system file, but we will soon import the files. First step after importing will be to let R know which are numeric and which are factors. By default, everything is numeric. If there is any variable in which at least only one is text, for example here, if instead of this 160, if it is written ABC or simply written A, so this complete displacement will be taken as text. Look for the precedence. If in the column even a single cell contains one alphabet, the entire column will be taken as the text. Entire column will be taken as the text. If there is all numbers, it will be taken as the numeric. If you wish to like 46801, if you wish to tell that it's not numeric, you need to convert it to the factor. So these are basically these three things. Text, you will not discuss that much. There is a complete branch in the text analytics. So we have the left out with the two, either numeric or factor. So you need to tell what are the factors. You have worked with the 3 seed quality levels. So tell as factor seed number A, B, C or 1, 2, 3. 3 sort of fertilizers are there, 5 fertilizers, name them. First thing is tell whether it's a numeric or this. Now we can work on it. So to work on it, basically a couple of commands are there. Summary is a fantastic one. If we write summary, not C, now CC. Okay, or otherwise there is another called table. Table is a very multi-purpose one. Table. Now table is the same command for univariate, bivariate and multivariate. See, this is amazing thing. A same command for all. Now all the time we should know where we are. So just see here. Now I am talking about this one. When there is one variable and that is non-metric, what we can apply? Count and percentage. The command for that is table. You can write summary also, but table is a good one. And in the summary tool, there is a frequency. If you use summary tool frequency, it gives you a little more systematic. Like the problem here is, if I ask you of the total cylinders, total vehicles, what percentage is of 6-cylinder vehicle? Of the total number of vehicles, so total vehicles are 32. What percentage is 6-cylinder? So 7 by 32 into 100. You need to do these computations. So for that, we can use summary tools. In the summary tool, frequency, and let me put it as CC. Summary tool, frequency. So summary tool frequency will give me output like this. It's more like SPSS. So this is the frequency out of 100. This is the percentage. Valid percentage. This is a cumulative percentage of the total. So what is meant by the valid percentage? Valid percentage is there is no missing value, not available. If there is a missing value available here, then what will happen? Of the total number present, it will compute the. Are you able to get this? Let me explain it here. I asked for a question, gender of the respondent. Boy, girl. 60 said boy and 30 said girls, and missing is 10. So if we compute percentage, I will say 60% for the boy, 30% for the girls. Okay? But in reality, this is not the case. If I take total as 90, so 60 by 90, that is 67% for the boys and 33% for the girls. Do you get this idea? So this is called as the percentage and this is called valid percent. Valid percent means those who are actually present, 10 are missing, 10 didn't reply. So those who actually I know, out of those who replied, 67 were the boys, 37 this. And out of the total, 10% were the missing. So actually we do it like this, excluding this 10, we compute how many actually responded and that's called as the valid percentage. So since in this case there is no missing value, so NAs are 0. If there is any value 2 or 3, if it is 2, then this will be out of the 30. 32 minus 2 out of 30 it will, then these two will differ. Since there is no missing, it's the same thing. And this is the cumulative percentage. So it seems more like, SPSS. How to take it in MS Word? One method is to simply copy and take it to MS Word. This is one method. Other method is export. That we will do little later. So this is one method of doing it.
Sir, दोबारा
Simply copy paste it. Select, copy and paste. From the output, simply copy and paste it as code. This is one method. Second method is export. That I will tell little later because people often get confused. So now let's just see this one. We are done with the summary tool DESCR. When it is the metric data, use this. And please remember, this will be done one variable at a time. This will also be done one variable at a time. Table is a very short form, and this is gives you percentage, valid percentage, etc. Summary tools. So if summary tools is not available with you, you can just go ahead with table. Now the same table works fantastically if there are two variables. For example, come to this point now. This one, actually you should write here as table also. Of this. This is a wonderful thing. The same table command is for univariate, bivariate as well as multivariate also. So this is a bivariate. We can go ahead with this table command, and in the multivariate for flux cross tab, that is also in the table. So one is there. These are actually, it says it's a very brief. For example, there is only one command t.test, that is for test. Three sort of t-test, and then one is the Welch test. So you need to just remember those things with the help of arguments. Just see what is meant by this. So if my objective is to study, is there any association of Vs and A? Is there any relation of V-shaped engine and shaped engine and AM, automatic or manual? Or I wish to study, is there any relation of cylinder with Vs? Now see, this is non-metric, this is non-metric. When both are non-metric, which test we apply? Cross tabulation and chi-square test. So how to apply this cross tabulation? It's simply, now I want to write this here. I will take CC and AA. So just let me check. If I simply write it as A table CC becomes this, and if I write table AA becomes this. Okay. So what if I write CC comma this? It becomes the cross tabulation. It becomes the cross tabulation. So table can be used for univariate as well as bivariate, as well as multivariate also. So table can be used if you write one variable, it will give count of 1. If you write two variables separated by comma, it becomes bivariate. Cross tabulation, depiction into the rows and columns. And what about that cross tabulation? Now for that we will use something. Now onwards I will use a technique, it's called iterative process. Iterative process means every time I need to type this table AA to get into this. So what I will do, this output I will save into something. This output I will save into a new variable. So what I am doing, I am saying T is equal to this. So what is happening, the entire output of table I am sending to T, so that whenever I T, it becomes this. So this is one process I will use extensively in R. We take something's output, put it somewhere else. Then take output, put it somewhere else. Take output, put it somewhere else. We will do it lot. So entire table I have put into a variable called T. Now I can simply type chi sq.test chi and put T in it. Put T in it. Now we get a chi-square test. Pearson's chi-square test. Okay. So how we are doing? First we worked on the table, saved the table into this, and then worked on the chi-square test. Alternatively, you could have worked like this also. Chi-square test table CC comma AA. In Excel, that is called as embedded function. A function within a function. You can do this way also, but since it becomes confusing at times, so what we have done is table I have saved with the name of T. Table I have saved with the name of T, and get this. But then there is a red warning, values may be incorrect. Values may be incorrect. So chi-square test got only one assumption. What is the assumption for chi-square test? Otherwise it is called a distribution tree test. It simply says you should have a large data. So how they say it? The assumption says expected frequency of every cell must be greater than 5. Expected frequency, not the observed frequency. Expected frequency should be greater than 5. Now, have you done it in your PG level? How to find out the expected frequency? The formula is raw total by into column total by grand total. Have you done this sort of questions in PG level somewhere? So for this expected frequency will be total, it will be 19 divided by multiplied by 11 divided by 32. So when any of these are less than 5, so you will get a red warning. So if you get a red warning, what will do? So chi-square has some limitation. So whom do you expect will come out with the solution? If there is some limitation of chi-square test given by Carl Pearson, whom do you expect will give a solution to that? Fisher. So we will apply the Fisher's exact test. Fisher dot test T. Okay, this one is the width. So first right. Now two things we require. Now we are struggling at many parts. We are learning statistics. We are learning R. We are learning computer. We are struggling at many ends. So let's see. Let's write a flow chart. How to go ahead with it? I understand it's getting too much, but let's take it slow by slow. First thing, you should have a bivariate analysis. From the objective, you should get into the bivariate. From the bivariate, both variables are non-material. Then go for cross tabulation. What is the command? Table. Command is this. But for that, x and y Both need to be defined as dot factor. Okay. First define them as dot factor, then work the table to get the cross tabulation. Now save this into T and next go for chi-SU dot test T. This will give the chi-square value. What is the null hypothesis? Null hypothesis, there is a punchline. There is no significant dash between dash and dash. So this is a template. This is a template. So what you will write here? You write any of the words. The three words are relation, difference, or association. Any of the three words, depending on the scenario, between the two things. Because it's a bivariate, there has to be the two things. In my case, it's cylinder and transmission. There is no significant, and the term I will use here is association. There is no significant association between cylinder and transmission. So, there are three methods. This is separately. Hypothesis testing rules. These are the decision rules. What are the rules? The first one we generally teach in the PG level. When calculated value is less than table value, we say null hypothesis accepted. When calculated value is less than table value, we say null hypothesis accepted. Second rule, when P is greater than 0.05, null hypothesis accepted. P is the probability value. How much probability I get? P value is 0.009. Is it more than 0.05? No. 0.05. So it is less. Less means null rejected. Okay. So this one is a golden rule for every single thing in statistics. I usually ask my research scholars that if there is any sort of temporary tattoo, so please get a tattoo on your arm or something. This is something which will be used all the time. P greater than 0.05 for every single thing, all the things in the statistics. This is one golden rule. P greater than 0.05, null hypothesis accepted. And what is null? No relation, no association. And third rule is that of limits. This we will do in regression. The concept of limits, there is a concept of lower limit and upper limit. In these limits, we can write a symbol. If 0 fall within limits, null hypothesis accepted. So we will be provided by the limits. For example, we get the limit like minus 11.2 and 2.3. So if I put it on an x-axis, will 0 fall between these two? If I put it on x-axis, minus 11 and 2.3, will 0 fall between the limits? If 0 fall between the limit, null hypothesis is accepted. So these are the three rules. Almost in the research paper and everywhere else, you will find these two as most important. This is something we teach in statistics, and there, if you have done the questions, it always starts with go at the end of the book. There are some tables given. Look for the value of the t, and then check for those sort of things we do. But in research, mostly we work on the p. And what is this 0.05? Actually, it again is something. There is something called alpha and beta. Type 1, type 2 alpha. If you know about them, it's fantastic. So this is alpha actually. So the good news is alpha is fixed. For social science, it's 5%. It means entire management, commerce, economics, social science, psychology, education, all where it's 5%. Animal husbandry, horticulture, agriculture studies, it's 10%. medicines, it's 0.1%. Okay, so 0.0, sorry, it's 1%. Medicine. So 5%, 0.05 is 5%. So now we'll go ahead. If P is greater than 0.05, it means null hypothesis accepted. But here, if the assumption is there, expected frequency greater than 5, that is the assumption. If that assumption is violated, in that case, what we will do? Go for Fisher's exact test. Null hypothesis is the same and the decision rule is the same. P greater than 0.05, null hypothesis is accepted. That is the same. So this is the flow chart of cross-tabulation, cross-tab and chi-square. So one command is table, one command is chi-sq.test, one command is Fisher's vectors. These are in R. So this is of statistics. How R can help? R commands are one table, one is chi-sq.test. So that's here. chi-sq, and the third one comes Fisher.test. Fisher.test. So I wanted to check whether there is a significant association between cylinder and we checked with AM, etc. Now check with the second one, V-state engine and the state V-shaped engine and the state engine.
So expected frequency is greater than 5?
Greater than 5 for all cells. This is the assumption. If the assumption is violated, if assumption true, then use this. If assumption is false, then work on the Fisher's test. This interesting drama we will find always. Anything goes wrong with Fisher, Pearson will be there. Something goes wrong with the Pearson, Fisher will be there. Do you remember that? So I wanted to check whether there is a significant, my question is there any significant association between the number of cylinders of the vehicle, and the type of engine? Type of engine is V-shaped or straight engine. So you may write also, the name of the file is empty cars and research question. Name of the file, I think it's case number 3 perhaps. Yesterday we wrote one case, the second is this, or you write from start. First write the file name, empty cars. File name is empty cars. Research question. Research question is there any significant association? Is there any significant association between the type of engine and number of cylinders? Type of engine and number of cylinder. Now type of engine is actually two. It's V-shaped engine or straight engine. V-shaped engine or straight engine, and cylinders are 3, 4, 6, 8 cylinder. You have converted, so it's a bivariate. Both of them are non-metric. So first convert both as dot factor, that you have already done. Go for a table. Table will give you cross tabulation. Are you clear between the cross tabulation and chi-square test? These are two separate things. This one is a chi-square cross tabulation. Cross tabulation is putting the data into rows and columns. That's called cross tabulation. Other name for the cross tabulation in some books, you will find the name contingency table. This is other name, contingency table. Contingency table and cross tabulation is one and the same thing. Just in some of the books, some of the articles, you may find contingency table. Making table is one thing and applying test. We apply chi-square test. If there is a warning, then go for the Fisher test. And tell me your decision. This relation? Significant relation. It is a significant relation. Well, we do not have much time today. Otherwise, I would have explained in detail what is bivariate and why yesterday I was saying R and T are one and the same thing and cross is the same thing. Do remember the words. Whenever we talk of correlation and the regression, anything, but after the measurement is ascertained, you know both are non-metric. It's apt to call it as association, not the relation. It's not wrong if you call it as relation, that's okay. But association is a better word. So association indicates both are non-metric. Then generally we use the word association. One is metric, other is non-metric. In hypothesis testing, the word is difference. And when both are metric, the word is relation. That's why we write there is no significant relation, difference, association. There is a meaning of it. Why I am saying it? Why they are different? How they are different? So if you wish to know about it, and if you understand Indian English, then you can go for this video. This video can help you. So, understanding bivariate analysis. There I have explained it in detail how T and R are different. Are they different? Are they same? What are the differences? Why we call its difference, other as the relation, third as the association. There are two videos. Here I have explained it. Understanding bivariate analysis. The limitation is it's only in the language. So just little, if you pay attention, for the beginners we say it's perfectly okay. If you write the word effect, impact, whatever you write, it doesn't matter. You can't fool statistics. It basically depends on how many variables are there and the way you measure. You write anything, but it will be applied. But if you coin the correct term, then it's even better. Relation, difference, or association. So how we do it? So just start from here. We will make table CC and I think that was name was VB. So it comes like this. Let me save it in ABC. You know this ABC doesn't matter, it's a name, you can give any name. So chi_sq.test of ABC. Again red line means please don't go for it. Fisher test ABC. So it comes, what is this value? 3.523. E means 10 raised to power. E is exponential. 10 raised to power minus 6. So indices and sorts divided by 10 raised to power over 6. It's a very small number. It's 0.000003. Just see that. If you have somehow missed this indices and sorts, do you remember a raised to power m is equal to 1 over a raised to power minus m?
Yes, sir.
Indices and sorts, a raised to power m into a raised to power n, a raised to power n plus n, and so on and so on. Those things you remember?
Yes, sir.
So 3.52 e minus 0.6. It means 3.52 into 10 raised to power minus 6. 3.52 divided by 10 raised to power 6. 0.00000352. So it's a very small number. So whenever you find after e a negative, it means it's a very small find 4.717E08. Okay, since it's a positive number, it's actually 1 into 10 raised to power 8. It's 417 something like that. So after E, if you find a positive number, very large. After E, negative, it's a very small number. So this is a very small number and it is less than 0.05. So null hypothesis rejected. So when null hypothesis is rejected, next thing comes, then what is the association? What do you expect? If null hypothesis is rejected and you say significant association is there, then what is that association? What is your future prediction? Just look it here. It means now we'll go for something that is called percentage analysis. So let me complete this. If null hypothesis is accepted, okay. Go for percentage analysis. If null hypothesis is accepted, then it's okay, no relation. But if P is less than for this or this, it means null hypothesis is rejected, then go for the percentage analysis. Percentage analysis means now we go for two sort of stuff. If I ask you, of all the V-shaped engine, what percentage it is for 8 cylinders? For all the V-shape, total are 18. For 8 cylinder, 14 divided by 18. For all the state engine, it's 10 by 4 cylinders are proportion is 10 by 14. I could have done this way. For all the 4 cylinder vehicle, total are 11. What percentage, what proportion is of state engine? So 10 divided by 11. Okay. So instead of doing it manually, do you understand what is percentage analysis? We need to tell that this is a pattern which appears. No relation means they are equally likely. Anything can be anyone. So this is the concept of no one. Let's go back to the summary tools once again. Column and C table. C table is cross tabulation. So we are working on the C table. When we will work on the C table? Only when null hypothesis is rejected. Only when it is rejected, then we will go for it. If accepted, stop. So name was ABC. Name of my table was ABC. Let me try to do it. What with ABC? Yeah, it worked. Oh, it says something wrong. No, not ABC. Let me work on the two. The name was CC and B. Please check it out. What are you getting it? What is it? It's written by default. I have not given the third argument. So it says row proportion. By default it works on the row. Of all the 4 cylinder vehicles, 90% were state engine. Of all the 6 cylinder, they are almost equally divided. But for all the 8 cylinder vehicles, a majority were the V-shaped. So can you find the association? That in case of V-shaped engine, there was the 8 cylinders, almost in 100% of the cases. In case of state engine, a clear majority was the 4 cylinder. This is the association. So if we get one new vehicle with a V-shaped engine, I will know that you must be certainly will be having the 8 cylinders, and vice versa. Doing it from different perspective, if I want column wise, then we need to write one more argument, prop. PROP is equal to C. It means by default, if you don't write, it's like this. PROP is equal to R, that's a default argument. I have not written it. So by default it has given me row proportion. So let's do it C. Now we'll read it as of column proportion. Of all the V-shaped engines, 77% were the 8 cylinders. And of all the state engines, 71 were the 4 cylinders. Again a clear demarcation. that state engines used for cylinder can be shaped a majority 77% are the 8 cylinders. Column percentage, row percentage. See where is 100? 100. If 100 is written here, it's column wise. If 100 is written here, it's row wise. Are you getting it? This will be done only when null hypothesis is rejected. Then we'll go for this percentage. A third argument in this case is T. T is for total. It means out of 32, what percentage? 43%. 14 divided by 32. Of all the vehicles, 43% were V-shaped cylinder, 31 were this, 12 were this, and out of this. So 3 are the arguments. This third argument, by default, if you don't write, it will be read as R. The other two options are C and D. C for column wise, D for total. Okay? So if you just note down the statistics, because it's again important for you, so note down, if you have to write chi-square, what exactly you report in your paper? So let's write it, reporting chi-square test. So first thing you report cross tabulation. Second, chi-square test statistics, oblique Fisher. Third, if P is less than 0.05, go for the percentage analysis. Fourth, charts for chart. And fifth, higher order analysis, that is something like phi, grammar B, kappa, etc. So these are the 5 things we report. See, R is not to be blamed if you are not getting anything, right? Because we are constantly swinging between statistics and R. Now this is from the statistics. You should know these lessons. The first thing, phi, phi or grammar B. Now these are some higher order statistics. They have their own meaning. So we have done this. What is the command for this? The command for this is table. Chi-square. The command is chi-sq dot test. Fisher dot test. Percentage analysis, C table. Okay. And for the chart, we can make bar plot. So in blue are the commands in R. The same thing we do in any software. So that's why I said yesterday, software doesn't matter. When you work on Excel, you will go same way. When you work on SPSS, you go same way. So softwares are third party, that's a neutral. But the way we do, so we have done, just see from the top, we have done the table, then we have done chi-square test, Fisher test, C table. Okay? If you simply write C table, it will work. C table, summary tools. Okay? Simply C table will work. That VB, CC, prop is equal to C. So this will work. If you want to write summary table column, that is again the same. If you know the name, you can write simply C table. If you forget somehow, write the name of the package, then you can recall this was the thing. So now going lastly for my entire table is in ABC. Do you remember that? So what I write here is bar plot ABC. Will it work? Figure margins are too large. It says there is not enough space. Okay. So the chart comes like this. What sort of chart is this? Actually, in Excel also, every chart is of 3 types. A simple chart, stack chart, 100% stack chart. This is a stack chart. So what we need to write, we will write bar plot beside is equal to true. So they will become side by side. beside is equal to true. In R, we work on abbreviations a lot. So instead of writing true, T-R-U-E, you simply write capital T. That will do. Please remember, in the language of computer, these three are taken as same. When you want to write true, you can write it T, you can write it 1. All three have the same meaning. That's why when you see the YouTube videos, you are often confused, why it's 1, what is meant by 1? Whether you write it as 1, whether you write it as T-R-U-E or simply 1, it's meant the same thing. For color, let's do it as C, color is 2, 3, 4. So we get things like this. So have you noted one thing? I have taken the table and saved it into T and used here T, used here T, used here T. Else I could write barcode, comma, table, comma, VVSS. That's embedded one. We can write this way also. This is a more easier method. They save the output in something in ABC and then barcode ABC, chi-square ABC, Fisher test ABC. You need not to write all the time table this. Save its output somewhere and then go ahead. So these ones. You can get these values, you can save, you can get output, everything you can do. There are certain arguments, you will work on it, and then you get the barcode. So, is that okay?
Sir, can you switch from
State engine first.
to y-axis from x-axis?
Okay, that means you are talking about orange is equal to true. Are you talking about this? Yeah, horizontal is equal to true. Orange, R works a lot on abbreviations, a lot. Shadow we write that complete. Orange, and again, I have not written orange, I have written HORI, drop menu count, so that I know exactly what I should write. Is equal to true, it becomes horizontal. So our first point is over. That's in the 2x2 table. Cross tabulation is over. Are you with me? Okay. Some are simply physically present, mentally absent, and counting. Okay. Let's attend any next workshop, and next time we'll do it right from the start. Right from the start, we'll understand the thing. Actually, the point is, if you know about the statistics in detail, we can go very fast enough. I took some times back, I took a workshop in Delhi. That was a free workshop. So I asked all those who have attended any of my workshop earlier, who know about the table number 1, table number 2, only they can come. And within one day, we completed entire univariate, bivariate, multivariate. Because I need not to tell you what is metric, what is non-metric, what is table 1 or 2, etc. This done. So we can go very fast there. Else, if you know, I know about R, then I can teach you stats. The point is here we are working on both. We are working on statistics as well as on R. That's why maybe a little struggle, but no problem. We can do it. How to take the package, this graph out. If you want this graph, there is an export. Copy to clipboard. You can save as this image as BMP or PNG, JPG. You can save it as PDF or copy to clipboard, copy and paste it into the MS Word. Where is that chart? Okay, so taking it MS Word is not an issue. So now let's come to the second part. Let's do a simple one. Simple one is R. Finding out the R. So only condition for R is both should be metric. And we have no idea who's dependent, who's independent. So how will go ahead with that? Let's find out R between MPG, vehicle weight, and vehicle weight. Now what is your understanding? At the weight increases, fuel average increases or decreases? Okay, just tell me what is the average of your car? In 1 liter, how many kilometers you run your car? 12, maybe 15, okay, 12 to 15. What about your bike or scooty? In 1 liter? 30, 40, 45, right? What is your expectations about bus and truck? In 1 liter, how much kilometer? 8 to 10? Okay. In Haryana, it's written there on all sort of roadways. There is a cash reward for an average of 5. If you will give an average of 5, so drivers are not able to maintain that. 3 or 4. 3 or 4. 5 there is a cash award. So road roller, well, that's not for the average purpose. But the higher the vehicle, the lower is the average. Higher the vehicle, lower is the average. So if you make a graph of it, what sort of graph we expect? Like this, or like this, or like this? Okay. Second, the problem with the second is, after some time you will say, at particular rate, vehicle will not be able to move. Somewhere, whatever, if you do it like this, somewhere there will be a point where you say, no average vehicle can't move. It means there is a minimum one that is always there. A minimum is there, so it's perpendicular, not straight line. You need to think, we teach straight line functions, y is equal to a plus bx, but in real life, there is never ever a straight line relation. Particularly for the things related with human behavior. There is nothing straight line. There is nothing straight line. Your height increases and then becomes constant. Okay? If I take, let's make a chart of your learning. You are learning, I am teaching, the lecture is up to 4:30, but I continue, it's 6:30, it's 7 p.m., it's 9 p.m, okay? So at 9 p.m, practically you are not getting anything. You are saturated, but you only know, yes, we have to do like this. Okay? So that means minimum learning is there. See, this means, this chart means somebody fall on the ground, become unconscious. That's correct. Fall on the mid x-axis. Else you are just parallel to the x-axis, you are getting minimum of the things. Okay? So, can you tell me any two things which are not from the science, not E is equal to mc square, anything from our human life which share a linear relation? Think over it. Linear means unconditionally as the x increase, y increase. Minutely increase, but it increase. Can you tell me any variables, any two variables, not from the science? Not E is equal to mc square or f is equal to me, not from the science, from the human behavior. Our happiness, our awareness level, satisfaction level, loyalty, politics, these sort of things. Just see, leader and the motivation. Is it a straight line? Is it a straight line? As leadership increases, I don't know how leadership will increase, but whatever. Role of leader, motivation, after one level, there will be a saturation. See, do you agree that people in the military has a different training than you? Their physical capabilities are different than yours. They have been trained that way. You have a physical capability of whatever level, you have a physical capability. The people who are in nearby institute, I am Lucknow, and you, there is a different in the mental capability. Nothing good or bad about it, but you have something, some restrictions of yours. They have some restrictions of theirs. It means I am just saying, despite my best and the honest efforts to teach you entire life in one day, there is a maximum level you can take. Then comes a saturation. You say, please, we need to settle down. Yes or no? It means it's not like teaching and learning goes in straight line. After some time, it becomes separate. It becomes subject. Please think over it. Whenever we work on the real life situations, why you work with the straight line methods? Why you work with the straight line? All of you invariably always work on the straight line. Y is equal to a plus bx. You always apply linear regression, isn't it? Now the most important thing with R, let's see. R is a sense of statistics. Everything is R. And Carl Pearson was very categorical when he said, I am specifying not a relation, a linear relation. So most of the time, this is a typical interview question. If R between the two variables is 0, can we conclude there is no relation? This, I think it was in IMD Gwalior. This was interview question. Everybody was asked the same question. If R between two variables is 0, can we conclude there is no relation between the variables? The correct answer is there is no linear relation. There could have been no linear relation. You remember age and height we yesterday talked about? Age and height is not linear. So if we try to fit R will say 0.1, 0.2. That doesn't mean there is no relation. We know there is a relation in age and height. Yesterday you made a relation also. But the relation is not linear. Do you understand it? Please lower down your expectations of R. R nowhere says I will give you a relation. R says I will give you linear relation. Remember this the word linear. It's the degree of linear estimation between the two variables. R never says I will give you a relation. That's why some things were taught to you when you were least prepared. Class 6, 7, 8, maybe class 9. You are taught about the parabola, ellipse, circle, coordinate geometry. You are taught so many things and you are the least prepared, least recipient what exactly these things are. So circle is something else, straight line, then curve, parabola. These are all different things. So coming back here. So your tea is ready. So just look for the commands for R because it's so simple. We can just write COR, MPG, WT. COR gives correlation. Okay. So total 4 commands we will do. COR is simply the correlation. A pattern is COR.test. COR.test, MPG.WT. Now this will not only find out the correlation, this is the correlation, it will check for 2 things. It will check for 2 things, whether this correlation is 0. Core test is a better one, it will check whether this correlation is 0. So, check for the null hypothesis, p value is very small. P value 1.2 into 10 to the power minus 10. So it's a very small. So R is not 0. There is some R. Okay. So let's stop here. 2 commands we have done. COR and COR.test. Rest of the 2 commands we will do after the table. Let's stop. Take your tea. There is a significant linear relationship. Correct. Let's stop here. Take a tea. सारे सब में किस तरह?
सर को लग रहा है कि स्टैटिस्टिक्स का वर्कशॉप बता दीजिए पहले.
Ma'am, again this comes. Switch off.